In this tutorial, we are going to learn everything you need to master dependency injection in C#. We'll use ASP.NET Core built-in dependency injection, and we'll try to understand all the possible practical methods of dependency injection, and we'll look to the different lifetimes like transient, scoped, singleton. We'll learn multiple injection mechanisms. We'll talk about keyed services and all the possible combinations related to dependency injection to master it, to apply it to your real-world projects. Hey, my name is TryAdd, and this is my channel where I share my knowledge about C#, microservices, GraphQL, Apache Kafka, Node.js, JavaScript, Transact SQL, all the possible tools and related technologies to these ones. If you like my tutorials, please don't forget to subscribe, hit like button, share, and let's dive in. If you're an absolute beginner in dependency injection, it would be better first to check our dependency injection in C# for absolute beginners tutorial and then come back to watch this tutorial. But anyway, I will try to explain everything from scratch. This is our decode bytes solution. As you can see, this is empty solution. I'm going to add new project and I will select ASP.NET Core empty project here. Why empty? Because in other type of projects we already have some generated code and I want to show you everything from scratch. So let's use ASP.NET Core empty and let's create our application. So it is going to be di deep dive.api. Okay, and let's create it. And voila, we have program CS here. The purpose of program CS is to build our application. After getting this builder, we'll be able to inject our services, add our services, and here we'll be able to provide our middlewares. Okay, I'm just going to remove this map get, and I want to show you one thing related to dependency injection. When I go to right click, add new folder and add controllers, you already know that we should create some sort of controller inside it. I'm going to call it account controller, which is going to inherit from controller base. Okay, and I will provide API controller here to use it for API and route that matches to the controller. Great. And I'm just going to return some sort of simple string information. Return hello from account controller. So in general, this is really simple controller, and when I wrote to account, it should work. Let's go for it and see. As you might guess, it will not work even I provide this account information here. The problem here is actually we don't have any controller logic here. It means in our program CS we need to add our controller knowledge here. First we need to provide to our template that please scan the assembly and find all the required controllers and add them to the dependency injection container. Okay, so let's provide it builder services add controllers. This will help us to add all the controllers. For example, here we have account controller, all the controllers to our dependency injection container. What is dependency injection container? Dependency injection container, let's think about it like a sub application in ASP.NET Core. Okay, so it means we have some sort of sub application which is able to register all the possible interfaces and their registrations in it. And after some class requires, for example, I have registered account controller, then someone requires account controller, then our system will be able to provide the instance of account controller. This is really simple. So AddControllers will help us to scan the library, scan the assembly, and check all the controllers and add them to dependency injection container. But that's not enough. We also need to when checking our route, we need to invoke these endpoints. Okay, and we are going to use app.MapController. Okay, now let's just go and run our application. Let's go for account, and here we are. As you can see, everything is working. This is actually the first step of understanding dependency injection in ASP.NET Core. Even you are not using dependency injection, built-in ASP.NET Core application will use it. Even you are using a simple application that doesn't need any dependency injection. For example, at least when you are working with controller, you are already using the dependency injection mechanism. Okay, cool. Now let's try to understand different lifetimes of dependency injection. As you might guess, we have builder, services, add, transient, add, scoped, and of course add Singleton. So we need to first differentiate this type of lifetimes. For that reason, I am going to have special services here. As always, I'm not going to make our project complex. For that reason, I'm going to have everything in one single library here. So let's call it services, and I will have another folder, clients. The clients is going to be our sub module, and our services folders classes will use clients. Our account controller needs some information about account number. We have account, and in our account we have account number. The value of account number is going to be GUID information. For that reason, we'll have special service, add new class, and it's going to be account number service. This account number service will use account number client. Okay, right click, add new class, and account number client. So it means account number service is going to be a wrapper, let's say a decorator over our account number client. I'm going to account number client. Let's just simply implement it. GUID get account number, and let's return GUID.new GUID. I think that should be okay. And let's go to our account number service, public GUID get account number, and let's just simply delegate this responsibility to account number client. Okay, we have account number client, and let's call it is get account number functionality. Great. Now let's go to our controller here, and in my controller I have injection mechanism. I will use account number service, so I'm going to inject account number service here, and let's make it private read-only account number service, and let's instantiate like this, and let's just use GUID get. It will return our account number service get account number. Great. Let's use our primary constructor called. And as you know from our first tutorial, we need to register this service here. So builder services add transient. Let's first register it as a transient account number service. To make things really clear, what I want to do, I want to have another injection here to not just instantiate, but inject this account number client. Okay, and let's go for it. Private read-only our account number client and account number client. Cool. Let's provide it like this. Okay, and let's just simply use account number client get account number, and let's use primary constructor. Now we have multiple mechanism here because our account controller will use account number service, but to instantiate account number service, we also need to register our account number client. Let's go for it. And here I'm going to use builder services add transient. Okay, this is going to be our account number, account number client. I want to have another endpoint here to show you the exact differences. First, let's check if everything is working or not. So you see, I have added all this stuff as a transient, and let's see the effect of transient here. I'm going to use account. So you see, I'm going to just refresh it, and voila, every time we are getting different values for transient service. So let's first try to understand the lifetime term in dependency injection. First, we need to try to understand the lifetime of our application. In our application, we have big and small lifetime, let's say. The big lifetime is when you start your application's lifetime is starting, and when you hit stop button, your application stops to work and the lifetime ends there, okay? And per request, we have a small lifetime. What is a small lifetime? This term is actually my terms to understand the general lifetime, the dependency injections, transient, scoped, singleton. And per request, for example, as a user, when I send request, this request will flow from account to service, from the service to the client, and will come back from the client to service, from service to my controller. This is my request lifetime, and our transient and scoped will be determined in the request flow, not in whole application flow. Okay, when you as a user registered your services, your clients as a transient, per request you will get different instances. It means, for example, this is going to be my first request, and in this case my controller will be instantiated using new account number service, and this account number service requires account number client. It will use new account number client every time for every request. That's why we are getting different GUID information after refreshing our page. Let's do it again. Debug, start without debugging. Let me go to the account here and let's just refresh. When I refresh, system will send a request every time per refresh. Okay, we are refreshing, the controller will be instantiated using the new service, new account number service, and your new account number service will require from dependency injection to provide new account number client. That's why you are getting every time different values for your API. But how about scoped services? Let's check them. I am first going to change all these services to AddScoped, and let's run it and check. You think that they should behave something a little bit different because AddTransient every time instantiates a new class, and scoped should behave a little bit different, but surprisingly we'll get completely different value for every refresh. So it means somehow transient and scoped working in a similar way. Of course not. The issue here is for one single request, when different services requires the same class to be instantiated, transient will instantiate different instance for your services, but for scoped service you will get completely same instance for your different services. let's see it in practice. So I am going to have completely different service here. And let's say it is our transaction service. Okay. And for transaction service, I am going to use approximately same behavior here. Okay. And let's use account number service, account number client. So I have two services. I have account number service and transaction service. They both are going to use our account number client. So let me update our flow here. So here we have transaction service. Our account service will instantiate transaction service also. Let's go for our account controller and let's provide our transaction service here. And let me just copy, paste, transaction service. Okay. And this is our transaction service. What I am going to do, I am going to generate data for transaction service also, and transaction service will use the same method here. And to make things really simple, I am just going to concatenate the response here. Okay, this is for my account number service, and let's go for transaction service. Okay. Great. Now we have some concatenated data. I just want to check them in practice. Let's go for first add transient. I'm going to add my all services as transient. Okay. Transaction service, and for the account number service also. So you see, now I have two services which will require one client. Let's see what we are getting at the end. I'm going to use my account. Let's hit enter. So it starts with 58999. Let's refresh. So you see, two values are refreshing, because when you use transient, it means if your application requires two different services to use same client per service, you will get completely different instances. It means you will get this instance and transaction service will get completely different instance. But when you change it to scoped, let's go for it. Add scoped, and add scoped. Let's run. In this case, our application will use a same instance for account number client. It means our transaction let's say our transaction requires account number client. System will provide new instance of account number client, but it will store this new instance for other services for one request. Okay. The only thing we need to change is, of course, our account number client, because when you request to this new ID, you will get completely different ID. What I want to do for the instance, I'm going to store this generated ID, and I will generate ID here to make our example really simple. So you see, in my case, here we have account number client that when we instantiate it, it will store this value and generate it, and it will return this value when you call get account number. Let me just run our application. Okay, let's go for account and let's just refresh. So you see 16 here, 51, but when I change it to add transient, I will get completely different value. Let's go for it. And account, you see 1A, 1D, 68, 26, and every time you will get completely different values. That's how we are learning the differences between AddTransient and AddScoped. The last lifetime item in our application is going to be our Singleton. Okay, let's change it to AddSingleton and try to understand the real value behind Singleton services. Okay, so when I run this application, I will get approximately same response, but the interesting thing here is when you refresh, you will get completely same data no matter how many requests you are sending. Okay, so in transient services, we don't have stability. We are getting every time different values. For scoped, we are getting same values only within one request. But for Singleton, we are getting same request every time until your application is dead. So Singleton lifetime starts when you run your application, and this lifetime ends when you stop your application. It means when you have some service as a Singleton, you will get same behavior every time until you completely stop and run your application again. That's how we are dealing with, that's how we are using our Singleton services. Now let's use different combination, different lifetimes for our services. We have used only the same lifetime for services and client. Now I'm going to change it a little bit. I'm going to inject our account number client using AddScope. It means in our case, if in one single request lifetime, not application lifetime, in our one single request lifetime, someone will ask our account number client, they will get completely same instance. Okay, it doesn't matter if it is transient or scoped, it doesn't matter, they will get the same instance. Let's check this behavior. So I have AddTransient, but now lower layer, lower module is going to be AddScoped. Now let's check it. And we should get completely same data. So you see 03, refresh to C0, C0, and that's how it behaves for different services. In above we have transient, for the low we have AddScoped. Let's change this one at Singleton, okay? At Singleton, you should practice with different lifetimes because in your application, you will mostly provide different lifetimes for your services. Now I have AddSingleton. It means for my application creation, I will provide account number service only one time. I will instantiate only it first time. But check this out. I am providing this one account number client at transient. It means every refresh, I should get different account number client. But let's run this application and let's navigate to account. And you see, we are not getting different ID, different GUID for our services. Why? Because our application will instantiate it only one time. And for the next times, it will ignore this account number service because no one requires this account number service. The required parts are account number service and transaction service, and they have already instantiated. No one requires account number client. Okay, for that reason, you should be careful. The upper layers, the upper layer in our case, the services like account number, transaction service, their lifetime matters for your lower services instantiating process. What I'm going to do, I'm going to our launch settings for my HTTPS because I'm using HTTPS profile here. Let's add our launch URL to account to not every time type account. And I want to do the via-verse operation here. So I'm going to change our lower layer to Singleton. And for the upper layers, I'm going to provide a transient, okay? Cool. So what will happen in our case, our transient services here will be instantiated every time, but they will get the same instance of account number client. And it means we'll get completely same value for our services. So 65, 65, and every refresh, it doesn't matter for us how many times you are sending request. Of course, it will every time instantiate transaction service and account number service. But in this case, our account number client is a singleton object. And it means for your services, you will get completely same instance. And for that reason, you are not seeing the effect of differentiating this transient and singleton services. Now I want to show you an interesting example of registering multiple instances of given interface. So we have account number client, and for account number client, I am going to have an interface here. Okay, and I want to register our interface. Means I will have add, let's say, transient, and I will provide account number client, and let's go to our services, and let's not use the exact instance, but try to use our interface for all services. Let's go to transaction, account number client, great. And why we're using interfaces, of course, if we have more than one implementation, then it is better to use interfaces. Otherwise, of course, it doesn't matter to use it in most cases. Right click, add class, and let's call it default account number client. This default account number client is going to implement our account number client, and let's generate, and every time we'll return a simple generated GUID. Let's generate it, and here we are. Let me just copy and paste it here. It means we have two different number client. The first number client is actually generating some value. This one is just simply using the static one, okay? Great. And let me just register it also. Default account number client. Great. And the question here is, which instance will be used for our account number service and transaction service? Let's just simply run our application. So in my case, I have all this stuff as a transient. I am just running it. And let's see, I am just refreshing. So you see, I'm getting the last value. Why? Because when you register multiple instances for your interface, system will take the last one. But if you want to have the first one, then you need to provide TryAdd transient. Okay, TryAdd transient. In my case, system will every time generate a new value. Why? Because it will not take the default one, but you see, it will take our original account number client, because it is optimistic dependency injection process, and it checks if there is some instance for your account number client, then it will not add it to your dependency injection container. Of course, that's not all. For TryAdd, we have TryAdd Singleton, like this, Singleton. We have TryAdd Scoped. It means for all your lifetime mechanisms, you have TryAdd functionality that will help you to do optimistic dependency injection management process. But that's also not a solution. Even you are taking the last one or the first one, this is not the solution. If you have registered, let's say, multiple instances for your class, in my case, I have account number client and default account number client. It means I may need this account number client for account number service, but this default account number client for transaction service. How to differentiate and how to take the exact instance we need for our application. Let's check. If you want to take, for example, not default implementation, but the original account number client for your account number service, you need to provide an enumerable here, okay? Account number clients here. And for account number clients, you need first take this X is account number client. That's how we are differentiating. So this dependency injection will provide all the instances here. Let's just debug and see the exact value here. I'm just running my application and here we are. Let's go for account number client here, and this account number client stores account number client because we are using the account number client. And let's just change it to default account number client and run it using the ease mechanism here. You can easily take whatever you want from your dependency injection. So you see, this is our default account number client that will return the same GUID every time. Of course, this was the solution for our .NET applications till .NET 8, and starting from .NET 8 we have really cool feature called AddKit. Okay, let's use AddKit Transient here, AddKit Transient for my application. For example, if you are using AddKit Transient, it is possible for you to use AddKit Scoped, AddKit Singleton, and you're providing the key AC1 here and AC2 here. That's all. And what you need to do, for example, for my account number service, I want to take AC1. Let's go for it. And here I'm just removing this IEnumerable. And let's use our aspect-oriented mechanism from keyed service and AC1. That's actually all. Let's completely remove this one. Let's use just account client. It means my dependency injection will take AC1, which is going to be our account number client. Let's debug it and see the exact value for it. Some services are not able, blah, 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 blah. And let's see why we are getting this error. Okay, because we are not using for the transaction service the keyed mechanism from keyed service. It will take AC2 and let's run it. And now we should be able to debug. Great. And here we are. We have account number client because for the given AC1 key, we have account number client. And let's debug our another service, transaction service here. It should take our default account number client. Let's run it. And here we are. This is our account number. Oops, we are using the AC the transaction. Let's debug. Let's remove this debugging from here and run it. AC2 for transaction, and it should instantiate default account number client. And here we are, default account number clients. Cool. So if you have multiple instances, it is of course the 100% possible case. In most of my projects, I always have this type of mechanism, and I've used it the IEnumerable one, but after migrating to .NET 8, it was able to use AddKit, Transient, Scoped, and Singleton.